This one is dedicated to each and every one of you who appreciate a great glass of wine. You know what I mean?
It's Monday. Let's raise a glass to the beginning of another week. It's time to unscrew, uncork, or saber a bottle. And let's begin exploring the wine glass. Today, I am sharing the first part of a fantastic seminar I attended hosted by Syria Wines in Paso Robles. The event was for industry and it was right up my alley. It was the science of taste. This is particularly near and dear to me as I have a published article in Wine Folly on the topic. See show notes for link. In fact, one of the images used in the seminar was taken from that exact article. What a pleasant surprise. This is a great seminar and has a lot of intriguing information. Please note that as with all recordings like this, the audio is not exactly ideal, but I think you will fully enjoy it. The second part of the education seminar will be next week, so be sure to come back. If you listen to a lot of podcasts, you know that many ask for Patreon. We do not plan on doing this, but I do ask your support by leaving a review. It takes only a few seconds of your time, but means so much to the show. The next best way to support Exploring the Wine Glass is to tell your friends. If you enjoy the podcast, your wine-loving friends will too. And don't forget to head over to the website to keep up on all things Exploring the Wine Glass. Slancha!
Give me the red wine. Give me the blush wine. Give me the white wine.
Hey everybody, I'm Lori Budd, a UC Davis winemaking program, Spanish wine scholar, sommelier service, champagne and Côte d'Aron specialist, and a WSET Level 2 graduate. You can find Exploring the Wine Glass on all the socials as well as your favorite podcast catchers. If you haven't subscribed yet, now's the perfect time to swipe, subscribe, rate, and review. Stay in the know about all things wine by visiting my website, exploringthewineglass.com. I promise I'll never tell you what to drink, but I'll always share what's in my glass.
That was new martini, Irish coffee.
Thank you, Terry, and your team, Cyril, John, Dallas, and thanks to Erica as well for connecting us. And thank you all for being here tonight. My name is Miguel Pedrosa. I am an associate professor of enology at Wine Folly. I am kind of brand new. I started for the fall quarter, and this is my second quarter teaching this wonderful group of students. They just had 1 hour of lecture and they came back for more. So.
Yeah. Because they got free wine.
Yeah, there's wine involved. More involved in wine for the lecture and all that, I'm pretty sure. Okay, so a little bit about myself. I was born and raised in Mexico. I studied food science and engineering there. So in my almost 1 year before I graduated, I had a life-changing experience traveling to France and here to the US in Oregon, where I got my wine bug, and that hit me pretty hard. So by the time I graduated, I decided that I wanted to do my PhD in enology, and I applied for a scholarship to the Mexican government, and they financed me for 5 years to study in Spain. So I spent 5 years in Albacete, that's central Spain, that's Sierra Mancha. Towards the end of that, I did a small research internship in Piacenza, in Italy. And then I graduated, and my wife, who's also a scientist, found a postdoc opportunity in Poligny, in Jura, in France. And I found myself unemployed. But a small winery hosted me for a year of wine production where I was making wine. Very happy. That's wage I've ever received. So I spent a year there in Jura working with yellow wine. And after that year, it gave me the opportunity to write a project on, I was curious about how is the brain making sense out of wine. So I applied again for money from the Mexican government, and they gave it to me. Years.
They would have seen him coming
I
by
did
now.
pretty well there. And I was able to be part of a neuroscience lab that was studying, that is studying decision making in the brain. So pretty much all of what you're going to see tonight is coming from those years. And after that, towards the end of my postdoc, I found the opportunity to come to the United States, and I was at Paso State. I was an assistant professor there for 6 years, and found the opportunity to come to California, and here I am. So the objectives for today's talk will be to describe. I want you to be familiar with the brain, and I want you to walk away with the idea that flavored wine is not in the bottle, is not in the glass, in your brain, and I'm going to demonstrate that. So we will talk about brain. Do we have any neuroscientists, neurosurgeon, medicine doctor? Okay, I'm going to be very cautious on how I explain. Please correct me if I'm wrong, but I did my best to be very much on target. So, and what you will discover is that indeed, pretty much all of our senses that are interacting with surroundings are actually figured out in the brain. So, and let me start with why humans consume wine. And these pictures here is maybe something that happened to you. You're sitting in this room because you may have already had this type of experience. You sniff, and you feel, oops, maybe you're experiencing pleasure, a memorable moment, rewarding moment. There's something about wine that is like this. So, and when you think about wine, well, wine is mostly water and ethanol. 97% of wine is pretty much that. How can water and ethanol make you feel like that? There's 3-4%, depending on the wine, of substances that can make you feel like that. That tiny percentage is very important. And we know that within that 30%, there's maybe about 9,000 molecules in different wines. But we have figured out in science about 9,000 molecules that contribute to flavor. So there's something about these molecules. And to go straight to the point, let's just start tasting wine. I will not speak forever, so I'll try to avoid that having the speakership. So let's just start with our first wine, which I believe is the one on your left. Right. So, and I want you to first, before you go into the wine, concentrate on the aroma of the wine. Go in there, do the gentle swirl, and concentrate on what can you and if you want to go ahead and give it a little taste, we can do so.
I would have, you ready? Give me like the miniature. Yeah. But if I see the
I want you to share with me the first impression on that aroma. Please.
Those apple gummy rings.
Apple gummy rings. Good. Yeah. One more. Honeysuckle. Yeah. So we have flowers, we have fruits, and for those of you who are wondering what you are tasting, we're tasting on a 2021 Union Road Creek. These are some tasting notes that will agree with some of your tasting notes as well. And I chose this wine because there is an intensity and there is fruit to it, and there is a number of molecules that are creating those perceptions that I think we will all agree that are pleasant. They are a little reward. When you stick your nose in there, they can give you some flavor. So, how is this sensation created? And what we know, of course, is that these flavors, these aromas, are coming from the vineyard, the cultural practices, region, the variety where it's being produced, the winemaking processing steps. All of that is contributing to the chemistry that is in the glass. And I'm not going to talk about that tonight. I'm going to talk about how we can perceive that wine flavor. How is our senses, the brain figuring this out? So a simple model for that is, well, you have the glass, which is a stimulus, and we get a response when we sniff, which can be a positive response like the guy on the top, but sometimes you can find wines that you don't like, and you can again have a type of phase or that avoidance of the wine. And in this simple model, one thing is that how do you get from a glass of wine to having those expressions? How can you create that with consumers? So there's something in between. From the stimulus, the senses are picking up those flavor compounds, and they're sensing, they're detecting them to ultimately create that outcome there. And the senses are the starting part. These senses are going to send signals to the brain, and the brain is going to figure out how all of this is coming into this overall sensation. So let's talk a little bit about the physiology of how are the senses working together with the brain to figure out these things. For the olfactory part, the aromas of wine, we know that, well, we have a glass of wine in there. There's volatile molecules that can fly, and we know that there's two ways to get them in contact with our body. So, and we have the orthonasal olfaction, we sleep from the air, and we have retronasal olfaction, when we breathe out and those volatiles are reaching one central point, which is the olfactory epithelium. That yellow area on top, I think I have another slide. Well, you can see the molecules flying. There are two ways to get there. Okay? Orthonasal and retronasal olfaction. From a chemistry point of view, we know that many of the molecules present in wine have different shapes, have different functional groups, different lengths. They look different, and these structural differences contribute to many of the descriptors that you mentioned. There's molecules behind each one of those descriptors. So these molecules here are going to be detected, are going to first start interacting with our body right there in the olfactory epithelium. And this is a zoom into that olfactory epithelium, where here we have on the bottom, you can see a volatile molecule with its wings. And that molecule is going to interact with olfactory sensory neurons. And these are the only neurons actually exposed to the environment. And there's this olfactory mucosa, that kind of watery layer that is going to be the interface between those volatiles that are flying freely inside of the nasal cavity. And once they are in contact with those olfactory neurons, they're going to start shaking things up. And they're going to stimulate these neurons. And what happens when you have this interaction between the molecules and the neurons is that there's going to be an electrical signal created. And that electrical signal, we can refer to it as a spiking. And that spiking is going to have a specific frequency. And the more of that molecule we have, more spikes we're going to see flowing up on the bottom up in that neuron. And it turns out that these interactions between volatiles and olfactory neurons, many molecules can interact with different types of olfactory sensory neurons or receptors. So a single molecule, here you have olfactory sensory neurons with different colors. That means that they're specialized in specific shape or specific chemistry. And a single molecule can interact with multiple of these receptors. And we have about 250 receptors. So there's plenty of places to interact. When we mention as well orthonasal or retronasal olfaction, imagine that that molecule is flying from the left to the right. So the activation pattern will have a different signature than when it's touching on neurons from the retronasal passage. So the direction will affect how that spiking is happening. That spiking, that's the message that something is there, that the volatile is there. After the olfactory epithelium, the signal is going to travel up into the olfactory bulb, and within the olfactory bulb, those globes, and they're called glomeruli, they will collect the signals from same types of olfactory sensory neurons. And the signal starts to go up. Now, at the olfactory bulb, now we reach the brain. And here is an actual picture of a real brain. And this picture is taken, imagine that you turn your head back and somebody's putting the camera on here, they're looking at you from here. And there's a zoom on the olfactory bulb on the right side of the screen, that OB, that little tiny, let me see if I can get closer to here. So, well, I don't have a cursor, but that OB, that's the first stop of that signal, the olfactory bulb. So, the olfactory bulb, if you follow the colored path, is connected to different anatomical areas that will be in charge of telling your brain there's something that has a smell in here. It's going to be in charge of detecting and starting to classify the chemistry of that stimulus. Right after the primary olfactory cortex, which includes the APC and the PPC, which is then for anterior and posterior piriform cortex. The next stop here is the amygdala and the entorhinal cortex. These two areas are important because the amygdala is an anatomical region in the brain that is responsible or has been highly correlated with how humans express and feel emotions. So aromas touch very early in their signaling pathway on one of the emotional hubs in the brain. The entorhinal cortex, there abbreviated EC, the yellow part, has been related to reward, how humans code rewards, and how these rewards play in decision making, things that you like, things that you dislike, things that you will eat, things that you will not eat. It makes sense that when you're smelling, you make these decisions rapidly. And then the next anatomical region there, the HB or the hippocampus, that's an anatomical region related with memory or highly related with memory. There's other places, but this one is kind of specialized. So this explains why many aromas evoke emotions very quickly. One of the first things that you can do when you smell things is say, I like it, I don't like it. You can say, there's something here, I like it. And this is also one of the reasons why aromas evoke memories. They have a direct connection, a direct anatomical connection.
And now, a word from our sponsor. Exploring the Wine Glass is brought to you by Dracaena Wines. Dracaena Wines is an artisan winery located in Paso Robles, California. They have been producing wine since 2013. Their first vintage began with one wine, their classic Cabernet Franc, which received a 91 in Wine Enthusiast. Since then, they have increased production as well as expanded their portfolio, have received many accolades including multiple double gold medals and consistent 90+ ratings. Visit their website www.dracaenawines.com or use the link in the show notes to schedule a private tasting and to see their entire portfolio. Purchase your award-winning wine and let Dracaena Wines help turn your moments into great memories.
So this is another view of the brain. Again, we have our volatile molecules in there, the olfactory bulb in yellow, the PC, the piriform cortex, and connections there to the amygdala, the renal cortex, hippocampus. All of these things happening in 260 microseconds. Right? After 260 microseconds, you can already detect these things. After that, that PC, the piriform cortex, is going to start projecting or sending signals to the thalamus, which is the central hub for central processing in the brain, and also to the insula and the OFC. OFC stands for orbitofrontal cortex. That's the frontal part of the brain. And that OFC is a place that will receive inputs from all the senses. It's kind of a multi-sensory hub in the brain. Importantly, the insula is one place where taste is going to land as well. So this blue part is going to be in charge of the detection, the identification of the molecules. We're going to start creating emotions, hedonicity, the intensity of the aromas. And then we can touch pretty quickly on memory. And the latest part of the processing is going to start combining this sensory input with cognition, your training, your knowledge of wine, decision making, complex decision making, and start gluing it together with other senses that we're going to cover in a few more slides. So all of these again is pretty quick, a pretty quick process. One of the challenges of olfaction is how do you name words? And when you think about that, all of the anatomical regions that I showed you before are not really the places in the brain where you would go to get your words. To do that, and there you have the PC, the piriform cortex, the primary olfactory cortex, and then in the first panel, or light blue panel, one of the next sections there is the OFC, that frontal part of the brain, that multisensory hub. And that olfactory sensory, that OFC orbitofrontal cortex will need to send some signals to a different brain region, the pre-Sylvian language network, depicted in the bottom part, to start sourcing words, getting words to describe what's in there. And then when you find the words in your head, there's another set of, or another section in the brain, inferior frontal gyrus, that's the green panel at the end, that is going to be responsible for actually verbalizing those words. So unless these connections are made, you cannot name, or it's very hard to name what you are smelling. Therefore, when you practice your tasting skills and naming, it's a muscle. You need to create those connections. You need to grow that muscle. The more you work out, the easier it gets to actually verbalize these words. And the power of words in olfaction is something fantastic. I see it every quarter with my students when we're tasting wine and wine, like today or tonight. And I'm giving them, please tell me what can you sense? And it's often the case that there's something I know but I just can't name. And then, if I cue them with the right word, that word will stick pretty strong. In a very influential study, a group of researchers had cheese aroma, collection of molecules, cheese flavor, and in this experiment, they gave participants the choice of, or they cued participants and say, this is cheese. And they asked them, how much do you like it? And then another group of participants received exactly the same aroma, but this time they said, this is body odor. Body odor, like armpit. So, but it was exactly the same aroma, the same stimulus. And what you can see on the slide, on the left-hand side of the slide, is what happened to the pleasantness rating. So on the Y bar, you have the cheddar cheese, and the pleasantness was around 0, so you didn't, not necessarily disliked it. But when the same aroma was delivered with the word body odor, then it became very unpleasant. So when they actually went to scan their brains while they were sniffing through these aromas, what they found is that some of the regions that were most active during that olfactory phase were the orbitofrontal cortex and the amygdala. Not very familiar. This is how they look in a brain scan. So there's, I didn't mention, but there's a technique called functional magnetic resonance imaging where you can ask people to do things inside of an MRI scanner, and you can measure changes in the oxygen level in blood in different areas in the brain, and that's how we get those images of activity, functional magnetic resonance imaging, fMRI. So, and then when they were doing these correlations between the activity in these regions, well, they found that they were actually very well correlated with the ratings that participants were given. So, words can be a game changer in the way you perceive wine. For wine service industry, the words that we choose for presenting the wine can make a difference in the experience of our clients and our tasters. Let's go into sample number 2. Let me pay special attention to the color of the wine. This color is that wine telling you about maybe the winemaking behind it. Maybe some heat contact, likely possible. Is it the color?
Oh, I like about smell.
Maybe it's 8. Yes. More. Oh. Yeah. And then when you sniff it, do you have a confirmation of one of all of those options? You have oak in there, so maybe that color is coming from the oak. So there's things that you know from the visual world that are telling you what's going on as well with the aromas. So color is a fundamental aspect of the quality of wines. And what you're tasting now, it's a 2020 Grenache Blanc from Adelaida district. And color, again, we are seeing a slightly older wine with some different techniques, winemaking techniques. For color, what happens is that we're now using a different sense. We're using vision. And what vision means for the senses is that we need light. If there's no light, you cannot see the color. So that light is shining on your glass, and then inside of your eyeballs, there's specialized receptors, called photoreceptors, that are going to capture that light and make an interpretation of that. And those are columns and rows inside of the retina. And once they get activated, they're going to do the same thing as what we saw with olfactory sensory neurons. They're going to start firing up and sending a signal that there's color in here. And those signals are going to travel all the way to the back of the brain. And the visual cortex, which is all the areas that you're looking at right now, this is a highly specialized size of that cortical area is really, really big. We are humans, we are very visual animals, and we have many regions that can help us to figure out if things are moving, if things have different colors, if they have different shapes. So there are specialized places in the visual cortex that will help us to disentangle that complexity of light impulses. It's only light that is going into your eyes, and then the brain is trying to make sense out of that light. So, in the neuroimmunology world, there was a very influential study done in Bordeaux with students not as good as the ones we have here. And I will tell you why. Because these students they were tasked with, well, let's make a list of descriptors for red and white wine, which is what you can see in the slides. So on the top you have white wine descriptors, on the bottom you have red wine descriptors, and on the top, for white wine we have on the top lychee, flowers, honey, citrus, pomegranates, bananas, and on the bottom we have spices, oak, cassis, strawberries, blah, blah, blah. They're abbreviated. Just white wine and red wine descriptors. So they were tasked, they were given a white wine and say, well, pick from that list of descriptors which apply to this white wine. Okay. So every dot that you see there, that's one student saying there is lychee in this wine or there is banana. So the more points is the more popular the description was. As could be expected, this wine had barely any student was picking red wine descriptors in this stripe. Only a few dots on the bottom, right? Okay. So these researchers were very clever. They tricked their students. And they presented the same wine, exactly the same wine. These times they spiked the wine with some color, cyanide. And they asked the students, okay, so give me the descriptors that you find in here. What do you think happened? So suddenly, the same white wine with a different color lost all the floral and fruity character. And descriptors are mainly now for red wine. That's why I told you they are not as good as mine. So I would fail students doing like that. But the take-home message here is that color is able to create olfactory illusions. All of those are olfactory descriptors. And from the winemaking perspective, if you think, or if you disregard color as quality attribute of wine, well, let me tell you that you're absolutely wrong. You can enhance and potentiate different attributes, different olfactory attributes. It's not just the color itself. The color will influence how the wine tastes, how the wine smells. So you might be thinking, well, these guys were not trained enough, and maybe there's some expertise difference in their brains that they're not. Let me tell you that anatomically, we all have pretty much the same equipment. All of the regions that I showed you, if you're here and you're enjoying these wines, all of our brains have good functioning. But the one thing that is not the same is the level of training. How frequently do you actually take care on wine? And so there have been studies measuring brain activity between sommeliers and just regular consumers, finding difference in how the brain interprets wine. On this slide, what you can see is that there are different anatomical areas in the brain that will activate for just controls or consumers compared to sommeliers. And if you see on the left panel, I kind of put the comment in the bottom. So amygdala is percent, because yes, consumers are concerned about liking or disliking wine. That's kind of the primary scheme of emotion. They're very good at it. They're very, very good. But they might not be as good in thinking deeply about wine, which is what the OFC, the orbitofrontal cortex, the dorsolateral prefrontal cortex is doing. All of this is higher cognitive, these regions represent higher cognition, working memory, complex thinking, decision making, which is what most sommeliers and folks in the wine service are tasked to talk about the wine, describe. There's been other experiments with master sommeliers, also finding that the greater volume in some anatomical regions for sommeliers compared to consumers. And when you think about this, well, why? They're exercising. It's muscle. If you're doing push-ups every day, eventually your arms are going to swell, and you're going to get bigger muscle. Here is the same. So this has been tested and proven not only for wine, for perfumers and other professionals in the food and beverage industry. It's a similar thing. Yeah, so at this point, what we are going to do, we're going to take a little pause to get the next set of wines to move into the different
This has been another episode of Exploring the Wine Glass. Thanks for listening. If you have suggestions on what topics you would like me to discuss, please reach out on social media. You can find me on Twitter, Instagram, and Facebook as Exploring the Wine Glass. I am also on LinkedIn as Lori Hoyt-Budd. Of course, you can always email me at exploringthewineglass@gmail.com and sign up for my newsletter at exploringthewineglass.com. If you enjoyed what you heard, please rate, review, and subscribe to help others find me more easily. And most importantly, tell your wine-loving friends, because if you like the podcast, they will too. Podcast music is Wine by Kevins. Until next week, slancha!